A throttle position sensor reports the position of the throttle plate to the engine computer so that it can decide how much fuel to inject into the engine and many other things. Without this critical sensor, the ratio of the air-fuel mix would be compromised and the engine would likely stall. In internal combustion engines, the throttle position sensor is on constant alert, sensing the necessary power demands to ensure a smooth ride. Making these sensors starts with printed circuit boards. These boards will ultimately process physical data and convert this into information the engine computer will understand. A robot transfers the boards to a conveyor, which takes them to a solder screen printer. The printer squeegees solder through a stencil to deposit it in specific locations on the boards. The squeegee and stencil then retract, and the conveyor shoves the boards forward to the next operation. Here, a robot retrieves electronic components from tape on a reel and deposits them on the soldered spots on the boards. It collects multiple parts from the reel at one time and installs them on the boards faster than you can blink an eye. Moving forward, the printed circuit boards arrive at a camera station. The camera clicks away and sends pictures of the boards to a computer. The computer analyzes the placement of each component. With the computers okay, the boards head into an oven with different heating zones. The oven melts the solder and then cools it down to fuse the components to the boards. The oven then ejects the sensor boards. Next, a technician serves them up to automated test probes. The probes energize the components on the boards and in the process collect information. They send the data to a computer, which analyzes the function of the components on the board and to make sure they're fully operational. Then the boards move to a pneumatic punch. It separates the 18 sensor circuit boards by cutting the tabs that hold them together. A worker assembles a metal spring to a plastic magnet holder. He places a high-wear washer over the neck of the magnet holder. Then he inserts the magnet holder assembly into the throttle sensor housing and places the unit in a tray. After glue has been injected in the holders, a robot moves in. It scans the holders and confirms that there's glue in each cavity. It then inserts magnets in the holders. A worker installs a torsion spring in the housing. It will hold the magnet holder tight to the throttle body. He now inserts the printed circuit boards into the sensor housings. Terminals in the housings mate to slots in the boards. He solders the terminals to the boards to establish the connections. All the parts are now in place for throttle position sensing. A worker places covers over the sensor board compartments. An ultrasonic welder then melts the plastic at the interfaces. Once it hardens, the weld bonds the cover to the sensor body. A robot pipes silicone adhesive on the welded seam to create a double layer of protection. The sensors ride on a conveyor that goes through an oven. This cures both the silicone on the welded seam and the glue inside to secure the magnet to the holder. Out of the oven, the sensors travel through a cooling station. Probes then power the devices and calibrate them for use in specific vehicles. A robot holds the sensor in front of a laser, which etches the date of manufacturer. Back on a conveyor, the throttle position sensor travels under a magnifying glass so that the laser etching job can be scrutinized. This throttle position sensor is now ready for detection duty.